Okay, so let's discuss a question from machine design. So you have a bent rod which is given and 30 kilonewtons is applied. So what is asked is at point A, what is the stress induced? Now if it is a horizontal rod and you would have applied 30, then it would have created a only axial loading, but you have a bent bar like this and you have a 30 like this. So this 30 has effect of the horizontal loading, as well as it creates a moment also at the fixed section. So, or basically you can get the reaction at the fixed center. So you will have a reactive load and also a moment. So because of these two, you have a stress induced here. So 30, this load P, let's assume it's a load P. Load P will have when you resolve it here, or when you see the effect of load P at this cross section, it will have a load, external load. So basically you are resolving a load has an effect of load and a couple at other point. So load P and a load M moment. So because of load P at the cross section A, there is just a pulling away force. So it's sigma by A, that is the stress due to load A, it's axial. Okay, whereas due to bending moment, it's you have a tensile at the top as well as at the bottom you have compressive, because this load P will produce a bending moment like this. So it's the top fibers will stretch and the bottom fibers will compress. So the top fibers will have a tensile stress and the bottom fibers will have a compressive stress. So because it's asked at A, so bending stress will be M by I is equal to M by I into Y. So because at A we have to add both of these. So the load is 30 kilonewtons and into area of cross section is basically 10 into 10, so that is 100. So it is 300 MPa for the axial. Now coming to the bending moment. Now the bending moment, we have to look at the cross section. The cross section is like this. Okay, so area moment of inertia is I, which is about the neutral axis BH cube by 12, whereas Y is half from the neutral axis. This is the cross section and this is the neutral axis. Okay, so from this, what is this side? So this is again H by 2. So this is H by 2. So once you compute I by Y, so what is I by Y? I by Y is the section modulus, and that you get as BH cube by 12 and given by, so H by 2, so it's BH square by 6. Okay, so sigma B is moment by BH square by 6, so 6M by BH square. So let's substitute. Moment is nothing but the load into the distance, so that is 30 into the distance is 50 mm by B is 10, and so everything we are substituting mm, the length units as well as the force units in Newton. So we get this as 1500 into 6, that is 9000, very high stress, in fact 9000 MPa. So that is the bending stress, that is actually due to bending, the axial stress, due to bending the tensile stress at A, and axial stress is again tensile. So both at A will have addition effect. So axial, because both are tensile in nature, the bending stress is tensile in nature and the axial stress is tensile in nature. So 300 plus 9000, so 9300 MPa is the total stress that is acting at A. Thank you.